One of the most important parts of any game is the camera controls. The player will be moving the camera almost the entire game, so it's essential that the camera feels good. So in this video, I want to show you how to write a robust, smooth camera control script that works for both mouse and gamepad stick input. I won't be covering character movement in this video. For that, I'm using Traversal Pro. That's a character controller asset I created. You can check it out on the Unity Asset Store if you're interested. Alright, let's get started. First, let's create a new script called View Control. We need a vector2 field named degrees to store the rotation of the camera. We're going to use the input system to read player input. So let's write a public method called input. It needs a parameter of type inputAction.callbackContext. We need to separate mouse input from stick input because they mean different things. Mouse input represents an absolute offset, a one-time movement where you're saying you want the camera to move with the mouse, then stop moving when the mouse stops. But stick input represents a velocity. So when I move the stick to the right and leave it there, I want the camera to keep spinning to the right until I let go of the stick. This all means we need to record mouse and stick input separately. So let's write two more vector2 fields and name them mouse input and stick input. I used to actually create two separate input methods, one for mouse and one for stick, but I discovered there's an easy way to get them both in this one method. In the input system, controls that represent one-time offsets, like mouse input, are all named delta, so we can just check if that's the control's name, and if so, record it as mouse input. Otherwise, we record it as stick input. And that's it for reading the input. Now we need to use the input. So let's add an update method. We need to add the input to the degrees field, but we need to swap the values around and negate the Y input. But why on earth would we need to do that? Well, that's because of the way rotations work in Unity. A great way to visualize this is to hold out your left hand and make a thumbs up sign. Your thumb represents the axis of rotation and your fingers point in the direction of rotation. With your thumb pointing up, that represents the positive y-axis, or the up direction in Unity. Notice that your fingers are pointing to the right. This tells us that if we add positive values to degrees.y, then the camera will look to the right. The problem is that when you move the mouse or stick to the right, input.x becomes positive. So to get the effect we want, we just need to add input.x to degrees.y. Now if you turn your thumb so it's pointing to the right, along the positive x-axis, notice that now your fingers are curled downward. This means that if we add positive values to degrees.x, then the camera will look down. So if we want the camera to look up, then we need to add negative values to degrees.x. But when we push the mouse or stick up, we get a positive input.y. So we need to negate input.y and add it to degrees.x. Then we do the same thing with stick input, but we also need to multiply it by time.delta time since it represents a velocity. The other thing here is that by default, mouse input will probably be way too fast, and the stick input will probably be way too slow. Let's add a few more fields to scale them appropriately. I found that a multiplier of 0.2 works well as a default for mouse, and 200 works well for stick. We can adjust these in the inspector, of course, and this will allow us to invert any of the inputs by negating one of these values in the inspector. And finally, we need to make sure we actually apply the degrees field to the transform. To do that, we'll just assign it to transform.EulerAngles. Now let's go set all this up in Unity. The view control script really just rotates the transform of the game object it's attached to, so it can be attached to the camera, a parent of the camera, or something else entirely if you want. I have a child game object under the player named View that I'll attach it to. Then I have the camera childed under View, but you could also keep the camera outside the player's hierarchy and use some other system like Cinemachine to make the camera follow the View game object and match its rotation. I've got the player input component on the player game object. This needs a reference to an input action asset. In Unity 6, there's a great default one that will be part of every new project, but if you want to recreate that, you can go to Edit, Project Settings, Input System Package, and click this button. In the player input component, I have the behavior field set to invoke Unity events, so we can hook up that public input method we wrote. Let's expand Events, Player, and click the plus button in the Look action. We'll drag in the View game object and select the View Control Input method. Now, if we press play, we should have working input. Both mouse and stick work. I can rotate it left, right, up, down, and the sensitivity feels right. But if I keep rotating upwards, I just do a full circle. So let's go back to the code and clamp the vertical angle. We'll add a max pitch field so we can decide how far the camera can look up or down. And by the way, pitch means up and down rotation, and yaw means left and right rotation. Then in update, after we apply the input, we can use mathf.clamp to clamp it. Let's go test. Okay, that's working. And let's make sure we can reduce the allowed pitch. Alright, that works. The next problem we should fix is that if I rotate the player, then press play, the camera just snaps back to 0 degrees. So when this script gets enabled, we need to read the transform starting direction and convert it to the matching pitch and yaw. For pitch, we just get the angle between the starting direction and vector3.up, then subtract 90. For yaw, we need to use the atan2 function. atan2 takes in a 2D direction and returns the matching angle. This function wants the y value first, then the x value. But since we want to give it the flat direction on the xz plane, we pass in direction.z instead of direction.y. atan2 gives us radians, so we need to convert them to degrees. But we have a problem here. atan2 actually gives us an angle in the traditional math coordinate system where the positive x-axis is 0 degrees and positive angles rotate counterclockwise. But for unity transforms, 0 degrees is actually the positive y-axis, or z if you're looking down at the flat ground like we are in this case, and positive angles rotate clockwise. Fortunately, the formula to convert between them is actually really easy. It's just 90 minus. So to get unity degrees, we do 90 minus math degrees. Alright, let's go test. Great, it's working. The next problem we have is that if you move the mouse slowly, you can see that it's very jerky. That's because the mouse input is reading the number of pixels as a whole number. We can fix this by smoothing out the mouse input using Unity's smooth damp function. To use smooth damp, you need 4 things: a smooth time value, which determines how snappy or smooth the smoothing is, a current value, which is just our degrees field, a goal value, which we'll name degrees goal, and a velocity value, which we'll name degrees velocity. Inside onEnable, we want to make sure we reset degrees goal to degrees and degrees velocity to 0 by using the default keyword. When you use smooth damp, you have to change your code so that the input is now modifying the goal value rather than the current value, because the job of the current value is now to smoothly follow the goal value. That's an easy change here. We just replace degrees with degrees goal here in update. And we also need to clamp the degrees goal pitch. Then before we assign degrees to the transform, we need to actually perform the smoothing. So we pass in all our values to vector2.smoothDamp. There's one more thing though that's special when you're smoothing out angles. You want to make sure the current yaw takes the shortest path to the goal yaw, because if the goal yaw snaps to the other side of the circle, the current yaw may end up taking the long way around. To fix this, we first want to make sure that both degrees.y and degreesGoal.y are between 0 and 360. The percent sign you see on these lines is the remainder operator in C#. It returns the remainder after a division between its two values. This allows us to convert angles that wrap around the circle back down to simplified versions that live between 0 and 360 degrees. We then add 360 and remainder 360 again so that we can bump up negative angles into the positive range. And don't forget the parentheses here. Then we check if the difference between them is greater than 180, and if it is, we add or subtract 360. Alright, let's go check it out. Awesome, that's way smoother. You can make the smooth time larger to slow down the acceleration, or smaller to make it snappier. And that's it for the view control script. There's a few other things I want to show you here in Unity. You can easily make this a first-person camera by setting the camera's local position to 0, 0, 0, and then deactivating the character mesh. And finally, I want to show off one of Traversal Pro's coolest features. You can create a working character controller with movement, camera, mouse, keyboard, and gamepad input in just a single click like this. And that's it. Good luck. I'll see you next time.